Computers in some vehicles calculate various quantities related to performance. One of these is fuel efficiency or gas mileage, usually expressed as miles per gallon. For one vehicle equipped in this way, the miles per gallon were recorded each time the gas tank was filled and the computer was then reset. Here are the miles per gallon values for a random sample of 20 in these records. So here's the miles per gallon records. They want us to construct and interpret a 95% confidence interval for the mean fuel efficiency mu for this vehicle. So we're given a sample, and from the sample, we want to construct a 95% confidence interval for the population mean. Okay, so let's go ahead and do our state then. State. Okay, we want to estimate the true mean fuel efficiency mu for this vehicle at a 95% confidence level. All right, so you can see, so let's do the plan. So you can see that n is equal to 20, which is less than 30. So we're not meeting that normal condition typically. So, and so we have this, and we do not know the population standard deviation, right? So whenever this cases arise, we need to use a one sample t interval for that population mean. Right? And I have here a little thing from your book. See, we can use the one sample t interval if sample size is at least 15. The t procedure can be used except in the presence of outliers or strong skewness. So we can see that we do fit that criteria. It's at least 15, but when it's in this category here, we need to test if the sample distribution has strong skewness or outliers. Okay? And let's go home. So we're at the home screen. Now let's go to table. Okay? And I'm going to input those points or those data points, right? Okay, I input the data, all 20 of them, right? Now, what I'm going to do is I'm going to label this as miles per gallon, okay? I'm going to enter, press enter, and then I'm going to go to menu. I'm going to go to statistics. I want to do stat calculation, and I want to do one variable statistics, okay? The number of lists will be 1. And I want to do it for the miles per gallon, the one I just created, and I want the results to be in the B column, okay? In the next column next to it. So, okay. So here are my one variable statistics. I have X bar is 18.48. I have the standard deviation of X is 3.11. Remember, this is the one I'm interested in because we're looking at the sample standard deviation, right? I have my min, which is going to be useful to determine if there's outliers. I have quartile 1, same thing. I have the median. I have quartile 3, the max, and that's the relevant information that I need, okay? So now what I'm going to do is I'm going to put these in the problem, and then we're going to test for outliers, and we're going to test to see if it's strongly skewed or not. Okay, so as you can see, I filled in the data from that one variable statistics that we did on the calculator. So now from this, let's go ahead and start our outlier test, right? Or outliers test. So it was a quartile 1 minus 1.5 times the IQR. Okay? So quartile 1 was 15.6 minus 1.5 times the IQR, which is quartile 3 minus quartile 1. So 21.25 minus 15.6, right? And this turns out to be 7.125, which is actually less than the minimum of the data, right? So at least that means there's no outliers the left of the data, right? Now let's check if there are any outliers for the right of the data. So that's quartile 3 plus 1.5 times IQR. All right, so quartile 3 was 21.25 plus 1.5 times IQR is 21.25 minus 15.6. And this happens to be 24.075. And we can see that that is bigger than our maximum, right? So that means we actually had no outliers, right? Okay, so this implies no outliers. So there's actually one more thing we need. So remember, we're in this condition here. So if we have a sample size of at least 15, we can use the T procedure except in the presence of outliers. So we check that, or strong skewness, okay? So we have to check if our data has strong skewness or not. All right, so what we can do, we want to see how close the median is to the mean. If it's relatively close to the mean, that means the skewness would be slight, and then we can use our T procedure, right? So remember, our X bar was equal to 18.48, and the median is equal to 18.9. You can see it's really close. And the standard deviation of X is equal to 3.11, especially in terms of the standard deviation because it's really big, right? So we can see that X bar is actually less than the median, right? So this does imply that there is left skewness, right? So that means the data is left skewed. Okay, so a way we can do this is if the data, if the median is within half a standard deviation from X bar, then we're good to go. Okay, then the skewness isn't so bad. So half a standard deviation away would be X bar minus 0.5, right? 0.5 times the standard deviation of X. Oh, and then X bar plus 0.5 times the standard deviation of X. So this is half a standard deviation away from the mean, or that interval. So this is equal to, so this would be 18.48 minus 0.5 times the standard deviation of X was 3.11. And then this would be 18.48 plus 0.5 times 3.11. And if we do that calculation here, that would be 16.925 and 20.035. And as we can see, the median of 18.9 does fit in that interval. So this means that there is left skewness, but it is slightly left skewed. So we could write something like this. M is within half of a standard deviation of X bar. So it is only slightly left skewed. Right? So, our normal condition, in order to use the T procedure, is met. All right. So what we need to do now is our independent condition, or our 10% condition, right? So independent, 10% condition. Okay, so remember n is less than or equal to 1/10 of capital N, where capital N is the possible, is all possible records miles per gallon for this vehicle, right? So remember, n was 20, so 20 has to be less than 1/10 of n, or 200 has to be less than or equal to n. And I think it's safe to say that that will meet. Out of all the records for this vehicle for tank emptying and then filling back up, I think that's safe to have. So we have all conditions are met. So now we can do our do part. So do, okay. So n is equal to 20, which implies our degrees of freedom is equal to n minus 1, which is 20 minus 1, which is equal to 19. And I'll explain later what we're going to use this degrees of freedom for, especially when we go to the table. So right now, this is going to be a two-tailed t-test. So it's 1 minus 0.95 over 2 is equal to 0.025. So our critical value, t star of 19, is going to be, so we have to go to our table. So here is our t distribution. And notice we had that 0.025 because it was two-tailed, right? So we have, let's see, 0.025 degree of 19. Okay, so 0.025 right here, and then 19 here. Oh, I don't want all that. So 19, let me erase that. So that means it would be right here, the 2.093. Okay, so that's our critical t value. So it'd be 2.093. All right, so now our 95% confidence interval, right, is going to be x bar plus or minus t star of 19 times the standard deviation, the sample standard deviation of x over the number in the sample. This is equal to, so remember x bar was 18.48 plus or minus, so our critical value is 2.093. The sample standard deviation was 3.11 over the square root of 20. And then this gives us our interval. Well, I guess this gives us 18.48 plus or minus 1.458. And now this gives us our interval of 17.022 and 19.938. Okay, so here's our conclude. We are 95% confident that the interval from about 17 to 20 captures the true mean miles per gallon for this car.